So, welcome back. Having understood different zones on the PT diagram and also from the stream tables, let us now try to solve the tutorial where we can understand how to identify the zones. So, I got a first very small tutorial for you where with the knowledge what we have had till now, let us try to identify a given pressure temperature condition or given property conditions, identify the zones as shown in this slide. Before I go to the actual problems, I again would like to just go in brief through the summary of different zones, different requirements in 1 or 2 minutes. So, coming to this slide where I can see all these zones on the PT diagram, and to look at this graph I would normally use table 1 where if I have been given PT, what I will do, temperature is the base for table 1, I will get the value of P sat T. Alright, for a given temperature find out P sat T and now compare the given P with P sat T, and based on this comparison we can decide in which zone the PT lies or the state lies. Alright. So, on this diagram you can see pressure and temperature over here, and here you can see that if P is equal to P sat T, it is on saturation line which is this point. If P happens to be less than P sat T, that is at this red point where I will say it is in superheated vapor zone. If P is more than P sat T, we say it is in subcooled or compressed liquid region, or if P is more than P critical and T is more than T critical, we are in supercritical fluid zone. The next slide would refer to table 2. So, one can do the classification using table 1 or table 2 also, and given parameter that you would decide whether to go for table 1 or table 2. As you know, in table 2 we have got pressure as a base now. For this pressure now find out T sat P, and for this T sat P you compare the given value of temperature. Alright. So, the first condition is same for supercritical fluid. If now this T, whatever T has been given is equal to T sat P, we know that it is on saturation line on this LV line. If this temperature is more than T sat P here, then you are in superheated vapor zone. If this T happens to be less than T sat P, then you are in subcooled or compressed liquid zone, as simple as that. So, table 1 and table 2 could be referred to in this way. What is important to understand, just identify the zone and write in which zone this particular condition lies. The third condition also can be seen when you are on the LV line, when we are on the saturated liquid or saturated vapor. We know that if I see in PV diagram, saturated liquid would be given by UF, VF, HF and SF property that you see from steam table, and saturated vapor condition will be given as UG, VG, HG and SG. Different properties are given over here: thermal energy, specific volume, enthalpy and entropy. Anything that lies between UF and UG, VF and VG, HF and HG and SF and SG, we know that it is in two-phase zone. So, here we got a vapor and liquid staying together. On this side we have 100% liquid, on this side you have got 100% vapor, anything in between is vapor plus liquid. That means for a given system U would lie between UF and UG, V will lie between VF and VG, H would lie between HF and HG and S would lie between SF and SG. Alright. So, SF is less than S less than SG, or HF is less than H less than HG, or VF less than V less than VG and UF less than U less than UG, you are in a two-phase condition on this line. So, if at all is a situation arises where you find U lies between UF and UG, we know for sure that it is in two-phase condition, or S lies between SF and SG, we are for sure know that we are on the two-phase zone. With this background, with whatever we have learned till now, let us try to apply these conditions to identify the zone in which a given P and T or whatever two parameter condition, two property conditions would lie. So, the tutorial 1 identify the zone. Now, I will come to the actual problem. Before that, just understand these basic conversions